The next demo is actually mine, and it's let me try to share my screen. I'll share it twice. So here, let me share the documentation screen first. Okay, all right. So as you can see, we have a new article or new guide in our Llama Edge documentation section, and it's about calling external tools, which I think is one of the most interesting use cases for large language model. Large language model, of course, you can chat with it, but I think chatbot only goes so far, right? You can only do so much with chatbot. And if people talk about AI native application, a lot of them are actually talking about tool calling, meaning that's you are not only chatting with the AI, but the AI is not only do the thinking and the talking, but it's also do the decision and then have direct effect on its decision. So it will decide to do something and then do it, right? Instead of chatting with a person chatting with it, then the AI tell you to do something, and then the person may or may not decide to do it, right? So this allows large language models to perform direct actions, and OpenAI actually has it for some time now, right? So if you ask ChatGPT something, it may decide to search the internet, right? To trigger some web service and get the result back. And so but on the open source side, because in the past, the models has been mostly focused on improving the conversation experience. So not a lot of models are focused on, being fine-tuned to perform, tool calling. But things are changing very fast. And we now have, with the Llama 3.1, we now have, several great models that can do tool calling. So that's where we write this document, to show you how to use the large language model to control other tools and applications on your own computer, right? One of the use cases that we see from hackathon that we see, is that you may have a drone, and then or a small vehicle or car, something like that. That can it can be remote controlled. So you use the large language model and you tell the large language model what you want this vehicle to do, right? For instance, you can say, I want the car to go to that wall and take a look at what's behind it. So the large language model would be able to translate this instruction into function calls in Python programs and things like that, and send that to the vehicle so that it's instructed to go forward, certain amount of distance, and then turn and then take a picture and then come back, right? So there are lots of very interesting use cases that they can do once you connect the large language model to the real world, right? So so if you look at so this document, it pretty much goes through the process of downloading a model. Here is the Llama 3 model, but fine-tuned by Grok. So the goal of this fine-tuning is to make it more, to learn about what tools are available it can use, and then based on the conversation context, generate instructions on how to use the tool in order to follow up, in order to move forward with the conversation, right? Then you can use the automated Llama Edge API server to start this model, and then you can use a demo agent, which is what I'm going to show you right now. So this application is available at second state / LLM to do. It's a to-do list application. Interestingly, I think most of the application today are we no longer do Hello World anymore because Hello World is too simple, right? So most of the applications you see today are to-do applications. It's a way to demonstrate that everything works, right? So the setup I have here is that I have a Python program here. It's called main.py. And the Python program starts a embedded database. So it starts my SQLite database all on my own computer. And then it allows me to chat with it. Whenever I say something, it sends that everything I say to a remote server that runs the Llama Edge model that I've just shown you, the Llama 3 Grok model. And it's running on a remote machine that is, half a world, a long way from me, right? And the model would process what I said and then come back with the tools that's available to it. So I already told what tools are available to it in the system prompt, right? So it would detect, what tools it should use. And then the Python program, when it sees the tool use instruction, it will immediately perform the tool call, as we will see, and then get the results, automatically send the result back to the large language model, remote large language model. and the large language model would then go on and send us, a response. So let's see how it works. That's I think this demo is actually quite interesting. So Python 3 min py. So it just go on and say, it's a chat interface. User asks me to say something, right? Say, I want to write a README doc tomorrow. Okay, so to give it, would you like to create a task for you to remind you about writing the README doc tomorrow? So now it knows it needs to do the tool call. So I say yes. Okay, see here, instead of returning, the system didn't return a human readable, words. It just returns a structured data. It's called tool call. It's the name of the function. It's create task. Arguments is task, right? The README doc, right? So it gives back a machine readable response. The large language model didn't generate natural language. It generates a JSON that instruct the client to do some action. So tool here is so the Python program sees this. It knows it needs to call the create task function, which is the Python function, and pass the argument, write a README doc into that function. What that function does is that to create a SQL statement to update the SQLite database locally to put that to-do item in there. So, and once the tool has done that successfully, it's gonna return results, result okay. And the Python program, without my intervention, would send this result back to the large language model. Large language model knows that its tool call response has been handled. So it says the task to write a README has been created for tomorrow. Is there anything I can assist you with? I would also like to discuss a salary increase with my boss this week. Okay. So I tell the large language model that there's another item that I want to do, right? So do you want me to add the task as well? It's a little verbose. So I say yes. So what it does, I believe it's gonna send another tool call response back, which triggers the Python application to handle it. And it's again gonna call create task, and with argument discuss salary increase with boss, and update that into the SQLite database locally. So now the task to discuss salary increase with boss has been added. Any other task or request? I need to file a TPS report before talking to the boss. Okay, so I added another task that has a relationship with the previous task, right? Let's see what the machine says. So it doesn't ask me, say, do you want to add it or not? Now it says, the task is file TPS report. So it has a create task, and then it goes back, right? So it says, the system says the task to file TPS reports has been created. Is there anything else I can agree with? I say, show me all my to-do items. So the large language model doesn't know what my to-do item is because it's stateless, remember, right? So what it does is that it's going to return a tool call that asks the Python program to look up the database and see what the to-do items are, right? So you can see it's no longer the function is not create tasks. The function become get tasks, and there's no arguments. So the Python program queries the database and then gets results. Say result okay, and tasks, it's back an array. That's ID1, write a document, ID2, discuss salary, ID3, file the TPS report. So it sends this JSON structure back to the large language model. The large language model would be understand it and then to be able to formulate an answer, because it sees the result from the tool call. Now it says, here are your current tasks. So there are three, there's write documents, discuss salary with boss, file TPS reports. Now I say, I believe I have already, because I forgot, filed the TPS report. Okay, see if understand this, the request I'm implicitly making in this in this query, right? So in this query, it's successfully find out that I said I'm done this thing. So it's no longer a create task, or it's no longer a get tasks. It's update an existing task, and it knows that's the ID is free and status is done. Okay, so the status of your TPS report has been upgraded done. Is there anything I can help you with? So you see, it knows that with this sentence or with this request, I'm implicitly asking to update the status of the to-do item. So it records, it turns around and generates a tool call called update task. And update task is a Python function this Python client application knows. So it invokes this function And with the parameter that's it's given, right? So now I can do it again to say show me all my pending. Okay, so I believe it's gonna generate another tool call and get tasks, right? So it generates a tool call and then it queries the database again, and you can see the Python program returns all the 3 tasks. But the 2 of them has the status. Those all come from database, right? Because they originally all have the to-do status. So now the last one, because we update the task in the last one become done. So now it's smart enough to figure out the 3 tasks included in this JSON, which formulates the natural language to tell me that there's 2 current pending tasks, because there are 3 tasks, one is done, right? So there are only 2 pending. The pending is write a README doc and discuss salary increase with the boss, right? So this goes on. That's you can actually do a lot more. Like I said, you can have it send an email from your computer, for instance. You can have it set alarm. You can have it, to a robot to go do something, fetch a beer, something like that. So there are lots of things that you can potentially do by combining the tool with natural language that describes your intention, right? So I believe this is something that's very interesting, and there could be a lot of use cases, especially on edge devices, and to combine hardware with large language model, and to combine, so that the bot or the device can really understand human intentions and generate the appropriate actions, not generate the appropriate verbal response. That would help help us do a lot better. Anyway, so that's my demo.